Hi, my name is Fida Jalani, and in this video series, I'm demonstrating some of the novel features of my research called Software Defined Cyber Agility for Active Cyber Defense. I have developed this and an active SDN controller as part of my PhD dissertation. If you want to know more about my research and the controller, you can contact me at fidahussain.gilani@gmail.com, and other contact information is in the video description. So in this video, I'll be showing the ability of the active SDN to continuously monitoring for the purpose of active cyber defense. So the idea behind this feature is that any vulnerable host can be reachable to some critical services. If that is true, then we need to monitor all the activities of that client. A client can be vulnerable due to many reasons. For example, the client is sitting outside the enterprise, or the client is sitting, or the host is sitting inside the enterprise, but is reachable from the internet. For this purpose, we are using Dropbox as our event that the client is trying to log into Dropbox. Then we see that is the client reachable to other critical services. If no, then we do not need to monitor that client. If yes, then we need to actively monitor all the sessions that are originating from that client. By monitoring mean deep packet inspection unless or until the session is terminated. So this is a topology that I'm using for this purpose. I'm using H1 that can reach to Dropbox server H10, critical server H12. So in this case, when the H1 tries to log into Dropbox server, we designate S6. We can designate any of the switches or the router along the path to perform deep inspection. Now, the router is not doing the deep inspection. Instead, the router is rerouting the traffic to some security device that is doing deep packet inspection. And in our case, that is controller. Now, let's go to the demonstration. We run our active SDN controller. For this, we run the bash script to execute the controller. So once the controller is executed, we create this topology in the mininet. The script that creates this topology also creates two queues for each switchboard for quality of service control. So we run this script, it will create the topology. So once the topology is created, we are using H12 as our critical server and we are using H1 as our malicious host. So first we will establish a connection between a malicious host and our critical server to make the condition true as malicious host is reachable to critical server. Now, and as you can see, the controller dynamically establishes a path. Now we create two external windows, one for malicious host H1 and the other for our Dropbox server. We create two Scapy based scripts, one for malicious guy and the other for Dropbox. So the Dropbox server script basically listens on port 100 for any incoming connection, and then it displays the payload that it receives in this connection. So first we run this script on our edge on our host end, which is acting as Dropbox server. The next time the next thing we do, we run malicious script on our host one, which basically sends multiple messages to our server with different payloads. As long as the payload does not contain any malicious signature, it is forwarded. Whenever there is a malicious signature seen in the payload, the host is quarantined immediately so that it cannot communicate any further with any other host or server in the network. As you can see, once it receives that there is a malicious payload, it blocks that. You can see the messages in the log messages. You can see this in the log messages of the controller that this host is quarantined. So this was our demo for continuous monitoring.